In this video, we are going to study the difference between static and dynamic memory. What is the need of dynamic memory? What are the advantages of dynamic memory? And what is the importance of dynamic memory, allocation and deallocation? So firstly, what is the difference between static and dynamic memory is? Now we already know that there are different segments or sections of memory which gets allocated to our program whenever we write a program and run it. So you may have different sections which we have already seen, like code or text section, static or global section, also called as data section. Then we have seen stack section, and there is another thing called as heap section of the memory. So till now we have not seen heap. Heap is used in dynamic memory, allocation and deallocation. Now we know that whenever we execute a program, suppose the program consists of different functions. For example, you have a main function, and within the main you're calling a function f1. F1 is defined somewhere at the top or below. So whenever you call who calls the main function, the operating system. So whenever the operating system calls the main, within the stack, memory will be allocated for the main function, right? And whichever variables you use in main function, all those will get allocated memory here. Suppose you're using a variable a inside your main, then the integer value a, suppose if a is an integer variable, then a variable will be allocated 4 bytes over here. Okay, so in your main, whichever variables you use, they will get allocated memory within the memory which has been allocated exclusively for the main section. Okay, now from the main, you're calling another function f1. So what will happen? On the stack, some memory will be allocated for f1 function. And suppose you have a char variable c within your f1 function, then 1 byte will be allocated for the c variable. And whenever the execution of f1 function is complete, control jumps back to the main function, and then the next statements will be executed. So whichever memory was allocated, whatever memory was allocated for f1 function on the stack, that will get erased. That will get erased. And then you will be able to execute your program further. So what happens whenever you return back from a function, whatever memory was allocated to that function will get erased. That is why now the free space is available there. So suppose you call the function f2 from your main, this free space will be used for f2 function, right? Suppose within f2 function you're calling some other function, then above f2 you'll get some more memory for that other function, and then you'll come back to f2, and then you'll come back to main, and so on, right? We have seen all this in detail before also. So that is what happens when you're calling functions like main or any other user defined function. It will get allocated memory within the stack, right? Now what if the stack gets full, right? Means you have a very big program, large program, you have 100 functions in your program. Each function you have to call, one function calls the other function, and so on. Suppose your main calls a function f1. Suppose f1 calls a function f2. Suppose f2 calls a function f3. Suppose f3 calls, and so on, if you go up to f100 function, right? Once the execute, so what will happen? For main memory is allocated, then for f1 memory is allocated, then for f2 memory is allocated, then for f100 memory will get allocated finally. Once the execution of f100 is complete, then the memory will get erased for f100, and you'll go back to f99, suppose. Then you'll go back to f98, and so on. But suppose what happened in this condition, unless you completed the execution of f100 function, you will not delete any memory from the stack. Means what? At a time, for 100 functions, the stack had to be sufficient. But what if the stack is not sufficient to handle so many functions? To allocate memory for 100 functions, suppose the stack is not sufficient, What if it becomes full even just for the 50 functions? Once the memory is allocated for F50 function, suppose, then the stack has become full. Then how you'll execute or allocate memory for the F51 function? How you'll execute memory for F52 function and so on up to F100? So once the stack becomes full, then it is not possible to allocate memory for the further functions. So the stack will become empty only when the execution of a function is complete, right? So I hope you're getting this. Suppose in between, due to some reason, due to large amount of functions, if the function has lot of execution within itself, then lots of memory has to be allocated to it. So if there are so many functions, stack will become full at some point of time. So then your program will crash, your system will crash. You will not be able to execute. Maybe a laptop or your computer or your machine will get hang and it will not be able to execute further. So you'll have to force shut down your machine or something remedy you'll have to employ. So that is what has to be overcome. And to overcome that, you have to use the heap memory. So this was one disadvantage of stack. It may get full anytime. Okay, so that is why usually large programs implement the concepts of dynamic memory allocation. Okay, so this was one disadvantage, that is stack overflow. Okay, stack overflow problem. Now another thing that we have to understand is, suppose we have an array. We have an array ARR, and in our program we have given the size to it as 5. So in this array, maximum we can store how many elements? 5 elements max. We can store 1 element, 2 element, 3 elements, 4 elements, and 5 elements. But we cannot store 6, 7, 8, 9, and so on number of elements. So it is the fixed memory which has been allocated to the array ARR. Fixed memory, fixed size, fixed number of elements can be stored. Right? Now, if you want to store more elements, what you'll have to do? You'll have to do the insert operation, right? We have seen how to insert elements in array. For that, we'll have to increase the size of the array. We'll have, suppose the size of array is n, we'll have to do n plus plus. So memory has to be allocated again. But that is not possible always. Right? If your array has the fixed size, and if you are inserting or deleting elements, what is happening actually? Consider the example where you're deleting some elements from your array. Suppose the size of array is 5 elements. Okay, you have the 5 elements as X, Y, Z, A, and B. Suppose you want to delete an element. Suppose you want to delete the element Z. Then what happens? You do this way: X, Y, A, and B. And you'll shift the elements forward by 1 position because you have deleted one element. But the memory that had been allocated to this array was for 5 elements. So there is one vacant space at the end. Right? The number of elements has reduced, but the memory was allocated so that you can store 5 elements. That memory will not reduce. Only the number of elements that you have stored will reduce. But you want to store only 4 elements. So this particular last section or last block is occupying space, and that is unwanted. Right? This space is for 5 elements, but you have deleted an element. So there is one extra space vacant. But you want to store only 4 elements. So that extra space is extra, and that means it is simply occupying memory in your program. So ideally, what you would want to do, you would want to remove that memory which has been allocated. But if you are going for the stack, if you are going for static memory allocation, deallocation, it is not possible to remove this memory by the programmer, right? Whenever you return from the function, the complete array will be deleted. But you cannot like delete the memory on your own like this. This will remain as long as the function is getting executed. So to deal with such problems in which the size or the memory that needs to be allocated is changing, right? The memory that you need to allocate is changing because you're performing certain operation on your array. That is when static memory is not a good option. You must use the dynamic memory allocation and deallocation. So this was case number 2, wherein dynamic memory has an advantage. So second, we have seen that for the array handling problems. Now similarly, another problem with the array is what? Suppose you ask the user how many elements you want to store. The user will say, I want to store 5 elements. Right? So it depends on the user. If he enters at the output window, if he enters, when you ask him, if he enters the value 5, then the array size should be 5. If he enters the value 10 at the output, the array size should be 10. So this is also changing the size of the array. Means indirectly you're changing how much memory should be allocated to the array. Right? According to some parameter at the runtime, depending on the user, the size of the array should change. So what you'll write in your program, you may write a of something. You don't know what to write here, right? A of what you'll write here. The requirement of the user is changing again and again. Sometimes he wants an array to have size 5. Sometimes he wants an array to have size 10. So what you'll write over here, a of what, right? So this problem is also another problem that needs to be dealt with, which cannot be done with static memory allocation and deallocation. Similarly, if you want to decide how much memory to allocate to a particular element, suppose you want to allocate or assign large blocks of memory, or if you want to assign lesser blocks of memory, these conditions can also be handled by dynamic memory allocation and deallocation. Okay, so such problems like when the stack overflows, if the stack memory falls short, right? How much memory should be allocated for the stack section of your program depends on the operating system. Suppose we consider in this case 1 MB of memory has been allocated. Suppose that 1 MB is not sufficient, okay, such problems. Then array size, if you're deleting or inserting elements, or based on certain runtime parameter, the size of array is determined, or if you want to allocate different chunks of memory of different sizes, all these things we will learn in dynamic memory allocation. So that is done using the heap section of your program. Okay, now stack memory or stack section is based on your last in first out stack data structure concept. Now there is another data structure called as heap, but this heap memory is not based on that heap data structure. Okay, keep this point in mind. The stack memory or the stack section operates on the principle of stack, that is last in first out. But there is a heap data structure also in programming, but this heap memory will not follow that heap data structure. Okay, heap memory and heap data structure is different concepts. They are the different concepts. Okay, so now how we will use this heap memory so that we can have dynamic memory allocation and deallocation. So whenever you're using stack, you're using or you're following or you're going for static memory. Static memory means nothing but fixed memory. Static means fixed. And when you're developing your program, when you're writing the code, usually that time you will decide how much memory to allocate it on, which is the fixed memory. But if you're going for dynamic memory, its size is variable, right? As I mentioned, size of array decreases and increases. Size of array may grow or it may shrink. That means size is variable. That is possible with the dynamic memory. Okay. And to allocate memory dynamically or to use the heap memory means to allocate and deallocate memory by the programmer. If the programmer wants to allocate and deallocate memory, that time we are using dynamic memory allocation. But if static memory is being used, means stack section of your memory is being used, that the compiler and operating system will do. Right? If you write a of 5, where you're going to store integer values in this array, so 5 into 4, that is 20 bytes should be allocated to this array. This 20 bytes will be allocated by the operating system and compiler. You do not have to allocate 20 bytes. But if dynamically you're doing, and suppose you want to assign 100 bytes to this array, then this 100 bytes, you will have to do it, you will have to assign it to the array. Okay, compiler will not do it. So this is another difference between static and dynamic memory. In static memory, you have to tell the compiler and the compiler will allocate the memory. But in dynamic memory management, you will have to do the compiler's job, means you will have to assign or withdraw the memory. And to do this in C language, you have to use certain built-in function calls. Malloc, that means memory allocation, calloc, and realloc. Realloc means reallocation. These three functions are used to assign or allocate memory. They are used to allocate or assign or give memory. And this fourth function, free function, is used to deallocate memory. Means whatever memory you have given, if you want to erase it, you have to do it on your own. You have to call the free function for that. Okay, in C language, we have these four functions for allocating and for deallocating. This is in C language. In C++ language, you don't have functions as such. You have to use certain operators. In C++ language, you have to use new operator to allocate memory and delete operator to deallocate memory. Okay, so we are studying C programming language. So we will see these particular four functions. So suppose that I'm writing a program. So I have to include header files. Okay, I'm including 2 header files. Then I have my main function. So if I'm using the main function in my program, it will be called by the operating system. Whenever it is called by the operating system, what will happen? On the stack, certain area will get allocated for the main. As you can see here, this much is allocated. It is called a stack frame. Whatever memory is allocated on the stack for certain function, it is called a stack frame. And for that, we have seen that already. And for the main function, we have allocated the memory. Now in the main, if I'm having an integer variable a, which I'm declaring, so what will happen? Memory has to get allocated for this a variable, which is an integer, that is 4 bytes have to get allocated within this stack frame for the a variable. So I have done it here. I mean, compiler has done it. Now what I'm doing? Till now, everything went off well. We have seen all this. We know all this. Now we are going to use dynamic memory allocation concept. And always remember, the only way to use this heap memory or to use dynamic memory allocation, you have to use pointers. Okay, why pointers? We'll see it in a moment or so. With the help of pointers, you can allocate and deallocate memory. So see here carefully what I'm doing. I'm declaring a pointer, which will be a pointer to an integer, int asterisk p. Then I'm writing p is equal to int asterisk malloc size of int. Now how this will work? Let me explain. So p is a pointer to an integer. Okay, and whatever memory you're going to allocate using this malloc function, you're going to allocate some memory. Malloc, or you can call it malloc, means memory allocation. So you're going to allocate memory to store a particular integer variable or an integer value. To store an integer value, you need 4 bytes. Okay, sometimes you may need 2 bytes depending on your system. So the best way is to write size of int. Whenever you write size of int, what this function will do, whenever you call this function, it will return the size of integer. Size of integer, suppose on my system it is 4 bytes. Then size of int, instead of this, what will come here? Here it will come as 4. Okay, so it is nothing but writing like malloc of 4. So whatever parameter, it should be a integer value. Why? Because size of will return an integer value only. Like size of int is 4, size of float is 4, size of char is 1, size of short is 2. So size of will return an integer value like 2, 4, 1, and so on. So whatever value comes here, in this case 4, malloc will allocate. This function call will help the programmer to allocate 4 bytes of memory. Where? In the heap section, not in the stack now, but in the heap. You will be able to allocate or have 4 bytes reserved in the heap memory area. Okay. Now these 4 bytes have been given to the, have been reserved. Okay, 4 bytes have been reserved, or they have been booked, you can say, like how you book a room in a hotel. like that you have booked 4 bytes of memory in this heap area. Now what you want to do? You have booked some memory, you have reserved some memory. Why? Because you want to store certain value in that memory, right? So what you'll do, you want to store certain value. Now you may, in this case, want to store an integer value, right? But the compiler or the system does not know what type of value or what data type of value you want to store. Okay, because the programmer is going to do everything in dynamic memory management. That means you have allocated the memory. So you have to also tell which type of data you want to store in this memory which you have allocated. Suppose I want to store an integer value. Then to tell the compiler that yes, I want to store an integer value in this memory which I have told you to reserve, you have to write this typecasting. You have to write int asterisk. Okay, we are going to see malloc function in detail also later on. But now to explain how it works internally, consider this, that to tell the compiler or to identify what type of data you want to store, you must do the typecasting. Okay, so suppose you don't do the typecasting, what will happen? Means if you only write malloc size of int, then what will happen? Memory will get allocated and this malloc returns a void pointer back. It will return a void pointer. Void pointer means a pointer which can point to any type of data, which can point to any data type. But we don't want that because we want to store an integer in this case. That is why this void pointer has to be typecasted to the type of value which you want to store by this syntax, int asterisk. Suppose you wanted to store a float, what you would do? You would write, see here I'm writing, you would write malloc and pass the parameter size of what this time? I want to store a float, so size of float. And it will return a void pointer. So to indicate that you want to store a floating point value, you must do typecasting by writing float asterisk malloc. And you must write here the assignment operator and whatever memory has been allocated by the malloc function, it will have certain address, right? At certain address, the memory has been booked or reserved. That address will be returned. And if you are returning an address, where can you store that address? In a pointer p, right? What is the value of a pointer? What I'm saying, what is the value of a pointer? The value of a pointer would be certain address, right? And using the pointer, you can access the value at the address, right? So the malloc function, wherever it allocates memory in the heap, that memory is at a particular address. And that address is obtained. And since you have that address, you will store it somewhere. Usually where we store the addresses in some pointer, right? So p is equal to address. How p is equal to address? Because malloc will return the address. So p is equal to address. And using this pointer, you will be able to store the value in the memory. You will be able to access the value in the memory. So now this p is there in your program you have written. Okay. You first declared the p pointer variable in your main function. Now p is a pointer which is local to the main function. It is a local pointer variable of the main function. So wherever memory has been allocated for main in the stack, there memory will be allocated for the pointer as well, right? See, pointer also has to exist in the memory and that pointer will point to some location, right? Means your pointer will occupy certain memory in the stack and the pointer will point to the memory which you have reserved in the heap. I repeat, the pointer is also a variable. So it has to be allocated memory, right? The pointer has to exist. So it has to be stored at certain memory where in the stack. And this pointer will point to some location in the heap memory, right? I hope you have understood. So pointer also has to exist. How it will exist? It will exist only if it is existing in the memory. So pointer is allowed to exist in the memory by allocating certain memory to the pointer. Pointer will be there in the stack and it will point to certain data in the heap, certain address in the heap. Okay, I hope you have got this. Now, if you want to store certain value in your heap memory which you have reserved, you can do it using the pointer. How? If I write asterisk p, I want to store the integer value 10. So asterisk p equal to 10. Then what will happen? Asterisk p, whenever I write, you will be able to access that location. And asterisk p equal to means in that location you can store the value 10. Right? So this is how, after reserving the memory, you can store some value in that memory using that same pointer. So I hope you have got this. Now, suppose the memory in the heap. The memory in the heap also has certain address. Suppose it is 200. Now, this 200 will be what? It will be the address which is returned by the malloc function. Malloc function will return the address at which you have reserved the memory. In this case, it is 200. At the address 200, you have reserved the memory. So 200 will get returned to this pointer, means the value of the pointer will be the address, which is 200. Right? The value of the pointer will be the address. The address is 200, which has been returned by the malloc function. So that is what we have done over here. Right? It will point to the location 200. So the value of the pointer is 200. Now you have stored the value 10. Okay. Now if I want to again do the same thing, I want to allocate another location, another piece of memory within the heap. I want to allocate or reserve or book another piece of memory from the heap area. So again, the same thing I have to do. Suppose I'm using the same pointer variable. Suppose I'm using the same pointer variable p. Then I'll do p is equal to int asterisk malloc of size of int, another integer value I want to store. This time I want to store the value 20. So malloc will reserve this section of memory within the heap. And suppose it is at address 400, then it will return the address 400. And where it will get stored this address 400? In the pointer p. So p is equal to 400. And then the typecasting int asterisk so that you can store the value, integer value in this location at the address 400 in the heap. How you will store the value 20 in the heap? By using the asterisk p equal to 20. Right? This one. So now you have been able to store 20 at this address. But now this pointer is pointing to some other location. Initially, this pointer was pointing to this address 200 in the heap. But now this pointer is pointing to some other location within the heap itself. Which location? The location at the address 400. So whatever address is returned now, that is 400, that should become the value of p. So that is what I'm doing. I'm changing the pointer address. The pointer is pointing to the address 200. Now I'm changing it so that the pointer will point to the address 400 now. So now initially pointer was equal to 200 address, p is equal to 200. Now it became p is equal to 400. Right? But this location at the address 200 contains 10 and it will contain it forever if the programmer does not deallocate the memory. Right? It will be in your memory forever unless you deallocate it, because everything the programmer has to do in the memory allocation and deallocation, right? So this 10 value will be stored in the heap at the location of the address 200, but now the pointer is pointing to the address 400 at which you have stored the value 20. Okay, so so far so good. Now what I'm going to do, if I do not delete the memory, the heap will also become full one fine day, right? If I do not deallocate the memory which I've allocated here, if I do multiple times, I call the function malloc, different blocks of memory I allocate, finally the heap will also become full. And then it is a very dangerous condition or case, because then you are really helpless. If the heap becomes full, your system will totally crash or you will not be able to program further, right? So what is the solution is, the programmer, that means you, have to deallocate the memory whenever you don't want it. Means what? Whenever you wanted to store the data, whenever you wanted memory, you allocated it, you reserved it. So now when you don't want it, you have to erase it or deallocated it, or like you can say you have to check out from the hotel, right? So that can be done by cleaning up the memory in the heap, means by freeing the memory which you have allocated. Freeing the memory means deallocating the memory. So I'm calling the free function, as you can see here. So what I should have done is, before allocating memory again using this p pointer, I should have deleted, or I should have erased the memory which I had allocated for the first time. Right, this was the first time I did it. I had to deallocate, and then I had to allocate the second time. So whenever I allocate, after whatever operations I can perform, and then I have to free that memory. Okay, it's a good practice. For small programs, if you don't free it, it's okay. But for large programs, if you're having a big project, then it becomes a serious issue. You must free the memory. After freeing the memory, you allocate the different memory again. Okay. So when I do free over here at this position, what will happen? This memory at which I had stored the value 10 will get erased. Okay. So now this particular memory has been freed. This particular memory has been freed. And it's a good thing because you didn't want it, so you have freed it. And then I'm doing the malloc so that I can store the value 20. Okay. Now this was malloc for simple integer variable, a simple float variable, a simple primitive data type. Okay. If you want to allocate memory for an array, what you will do? So see here, if you want to have an array of size 20, suppose, so you'll have to store, if you want to store 20 elements, then the size of the array will be 20. But what will be the memory that you need to allocate? Suppose you want to store integers in this array. You want to store integers in this array. You want to store 20 integers. Each integer occupies 4 bytes. So 20 integers will occupy 20 into 4. That is 80. 80 bytes will have to be allocated. Right? 80 bytes will have to be allocated. So that is what you'll have to do here. Now 20 into 4 is nothing but 20 into size of int. So that is what I've written here. Malloc 20 into size of int. So 20 into 4, that is 80 bytes will be reserved. So a huge block of 80 bytes will be reserved over here, as you can see here. Now, if I'm reserving multiple blocks consecutively, array is a consecutive, it uses consecutive memory blocks. So these 80 bytes or 80 locations should be consecutive one after the other without any gap in between them. Okay. And now which address will be returned by malloc? If I stored a simple variable over here at the address 400, then the address 400 was returned by malloc. But if I'm storing an array, then the base address of that block of memory, which is in this case 50, suppose, then that base address, which is 50, that will get returned. Okay, starting address of that block of memory which you have reserved, that will get returned by malloc, and that will be the value of the pointer. So in this case, p is equal to 50. Right? And then just now in the previous program in which we saw pointers to arrays, using the pointers, we reverse the elements of arrays, right? So using this thing, p is equal to 50 initially. Then if you do p plus 1, it is like saying p plus 1 into size of int, which is 4. So you can access the next element in the array or the next element in the memory. So using the, okay, refer that video which I've already discussed, how to handle the arrays using pointer to an array. Using that, you have to allocate the memory. Using that, you have to store the elements in the memory. That means if I write, so initially p is equal to the memory block, that is the starting address of that block is 50. So if I write asterisk p, what will happen? At this address 50, I will be able to store some integer value, suppose 10. So at this address 50, I'm storing the value 10, integer value 10. So the locations 50, 51, 52, and the location 53. Right? 4 locations, 4 bytes will be used to store an integer value. So all these 4 locations you will use to store the value 10. Right? Now if I do p plus 1, what will happen? It is like saying p plus 1 into size of int, which is 4. So you'll access the location 54. And at that location means what? You must write it this way. P plus 1 means what? You are able to access the location 54. And if I do asterisk P plus 1 means at that means, and if I do asterisk P plus 1 equal to suppose 40, then at that address, at that location, in that memory, I can store the value 40. Right? So 40 will get stored at the location starting from 54, 55, 56, and 57. These 4 locations will consume for storing the value 40, will get consumed to store the value 40. Similarly, I can do asterisk P plus 2 so that I can store the next element, suppose 30. Right? Now, if you don't want to do this asterisk P plus 1, asterisk P plus 2, you can do it by the array style. If I write, okay, see here. If I write P plus P of 0 means P square bracket 0. It is same like saying P. If I write P of 1, it is same like saying P plus 1. It is same like saying asterisk P, and it is same like saying asterisk P plus 1. Right? So whenever I repeat, whenever I write P, it means the first position. And if I write asterisk P equal to some value like 10, means at that position I want to store 10. Or alternative way is you write P of 0 is equal to 10. Similarly, if I want to say asterisk P plus 1 equal to 20, then it is same like writing P of 1 equal to 20. Okay, so if you are getting confused asterisk P plus what, simply do like arrays, P of 0, P of 1, P of 2, and so on up to P of n minus 1. Right? I hope you have understood. So that's all for this video. And then if you want to free the memory, what you'll have to do, just a moment. If you have allocated the memory using malloc, if you want to free the memory, again call the free function for this pointer P, because P is pointing to this big block of memory. So free P, okay, so that you can deallocate the memory. This whole block will get deallocated. Okay, so that's all for the introduction to difference between static and dynamic memory, how you can allocate memory using malloc, and so on. Okay, so next time we'll see malloc, calloc, realloc, and free function in detail. So thank you for watching this video. I hope you have understood. If any doubts, you can contact me anytime. Thank you.